The multi-tier style or architecture is very common in style as well. Now, I have to say that the styles I'm saying are not distinct from each other. You can use multiple styles in the same application. Okay, so you can say you can use model view controller in a web server application. Okay, and all of them would be tiered. So what does it mean when you say multi-tier or multi-layered? Now, you organize your components in layers in which the bottom one, so it's as if you're laying bricks. Okay, so the one at the very bottom is the least independent. I mean the most independent, the least dependent, which means that this layer is just can be by itself. It can be compiled when you write all the code there and you can compile it. You don't need anything else. You compile this layer by itself. Now, if you have put something in a higher level, like similar when you're laying when you are laying blocks. Now, the second tier will be dependent on the first tier. So when you translate that to code, when you get to the implement, all the code inside this layer will not be able to compile unless all the code in the first layer is compiled. Okay, so that's how you can distinguish the dependencies. All right, now the third layer depends on both the second and the first. Okay, and so on. The higher you go in the layers, the more the dependencies you have. Now you can have two styles, either closed architecture, which means that every layer can access only one layer beneath it. So second layer can only access the classes or the services provided by the classes in the second layer. And the second layer can only access the services or the classes provided by the first. Okay, the fourth layer can only access the services or the classes that are provided by the third only, not the second, not the first. Cannot access them directly. So if a service from the first or second layer needed in the fourth, then a service in the third needs to provide this intermediate access. Okay, so this is the closed architecture. In the open architecture, every layer can access any of the services provided from all the layers beneath it. Okay, so if you are in the fourth layer here, you can access in your code any of the classes implemented in any of the components in the layers beneath it. So that would be called the open architecture. Okay, now there are two common ways that, I mean, there is no restrictions, but there are commonly, it is commonly found that a 3 tiers architecture and the 4 tiers architecture are the most beneficial in most cases. So three-tier architecture is just you have the interface. Okay, so these is an interface, and then there is the storage or the data interface and the data layer. And then in between is the application layer or the business logic. Okay. A fourth tier is that you take the presentation, I mean, you add an extra layer between the application layer and the user interface layer. So all the logic that handles the user interaction would be here in that added layer here. Okay. So these are common, like in most cases, the 3-tiered is the most common, but the 4th tier can be useful as well, especially when you have some complicated interactions with the user, and you want to refactor them into a separate components. You can use the 4-tier layers, or 4 tiers or 4 layers. All right, now the last pattern that we're going to talk about today is the pipe and filter. Okay, This is very commonly used in the data science applications and machine learning applications, but it's not restricted to data science or machine learning applications. It's a general design pattern that can be used in any application. It's just you have two main components, one of them of type filter, one of them of type pipe, and it's just you use them to process data or process information coming in multiple steps. So an example of that is the in the Linux commands, you have this piping. It's actually literally called the pipe, okay? And that is to take the output from one command and send it as an input to another command. Okay, and then in that step, you take the output from this command, send it to as an input to the second, and so on. It can keep going like this. Now, when you get to implement it, you just implement two classes, one of type pipe and one of type filter, and you will have multiple. I mean, not classes. You can have a parent class of type filter, and then all the classes that would do the processing would be of that type. And then you have a parent class of type pipe, and all the classes that do the transportation between the filters would be of type pipe. All right, and you can also, it's very easy to see how is that useful in data science applications and in machine learning applications, because you need to do multiple stages of processing of the data in order to get to the final result. But it can be used in any other applications like the example here. All right, so these are the design patterns that we're gonna talk about, and we're gonna talk about it some more when we meet in the class.